So, in our previous class, we have discussed about bituminous material as a pavement material, and we have discussed about different tests which is conducted to know the quality of the bituminous material or suitability of the bituminous material as a road aggregate. Now, in this class, we will discuss about cement as a pavement material. So, generally, cement is used as a rigid pavement material. Rigid pavement means the pavement which is constructed with the cement concrete. Now, cement is the most important ingredient of cement concrete or cement mortar. Now, there are different ingredients of cement which you already know. So, generally, for the road aggregate or road construction rigid pavement, ordinary Portland cement is used. Now, the primary ingredients of the cement are, as you know, that is tricalcium silicate, dicalcium silicate, tricalcium aluminate, and tetracalcium aluminate ferrate. Now, you all of you know about all these the component. Okay, their uses or their characteristics. So, I'm not going for a detailed discussions of all these component. Now there are different type of cement, and ordinary Portland cement is classified into three grades, that is grade 33, grade 43 and grade 53. But this thing is important for you, that is grade 43 cement is widely used for highway pavements since the heat of hydration and shrinkage cracks are less compared to OPC 53, but the strength of this OPC 33 grade cement is more than the grade 33. Now, in some cases also, rapid hardening cement is also preferred, and rapid hardening cement is preferred for the remedial jobs. Remedial jobs means suppose if you have constructed a pavement, rigid pavement, after some years, like suppose 5 years or 10 years, some portions of the pavement got damaged. Now, to for this remedial work, generally that rapid hardening cement is used so that it got or it gained its strength very easily and very effectively, and the pavement portion can be usable within a short span of time. Now there are different properties of the cement which is very much important for the rigid pavement design. Now, first one is fineness. Now, how to know the fineness? Fineness of the cement is known by sieving. Generally, sieve analysis is conducted with the help of IS 90 sieve, and the retained percentage on IS 90 sieve should not be more than 10% for ordinary Portland cement OPC and 5% for a rapid hardening cement. Now, another important parameter is setting time. Now, setting time is also important, and you know there are two types of setting time. And first one is initial setting time, and second one is final setting time. Now, initial setting time is very much important because if you know the initial setting time, in that case, you can have an idea that how much time you will have to place your concrete over the surface. Okay, now workable cement mortar paste using a desired water cement ratio is prepared, and the time taken for the paste to harden is noted, that is setting time. Now, temperature and humidity affect the setting time. Therefore, the standard values for testing are 20 plus minus 2 degrees Celsius, and your humidity is 65%. Now, setting times are classified into initial and final setting time. Generally, for the cement concrete which we are using for the rigid pavement design, that initial setting time is important because of the transporting, placing, and compaction of the concrete. Now, the minimum initial setting time for OPC should be at least 30 minutes. Okay, if it is less, in that case, you will have a lesser time to mix and place that concrete. Now, the final setting time is the time required for the concrete to harden sufficiently to attain the shape of the mold in which it is poured. Now, by this time, primary chemical reactions are completed, and for the OPC, which we are using for the road aggregate, that final setting time is about 10 hours. Now, another test is there that is called soundness test, which is tested by Le Chatelier apparatus. Now, this test is conducted to know the extreme volumetric changes of the cement mortar. Then chemical composition test. Sometimes the cementitious material may be composed of some impurities. For that, you need to know about the chemical composition or lime saturation factor of the cement, and this chemical composition test is conducted using a factor that is called lime saturation factor of a cement, and it is the ratio of calcium oxide to the other three main oxides present in it. That is calcium oxide, then silicon dioxide, aluminate oxide, and ferric oxide. So in general, that ratio should be in between 0.66 to 1.02 as per IS 269/1989. Now another parameter is strength. Now you know how to test the strength parameter. Basically in the strength test, we test the compressive strength of the cementitious material. We will mix the cement mortar, that is cement, with the sand and prepare some mold, and after that that mold will be tested under the compressive loading. Now for the road concrete, that is that mortar strength of this should not be lesser than 16, 22 and 33 MPa at 3, 7 and 28 days curing. Now there are different type of admixtures which are also used as a as a component for the cement mortar or cement concrete mix. Now there are different type of admixtures. Some are retardants which increase the setting time of the concrete, accelerator which accelerate the hydration for rapid strength gain, then plasticizers and super plasticizer which increase the workability of the concrete and reduce the water content, then air entraining agent. It improve workability and increase the resistance to frost action, and pigments to make it colorful. Now, apart from this, there are other type of admixtures also, and these admixtures are like fly ash, blast furnace slag, pond ash, rice husk ash, etc. Basically, these type of miscellaneous admixtures have the cementitious properties, and they sometimes used to replace a portion of the cement from the uh, concrete or mortar mixtures. Now, properties of the cement concrete. Now, first property is workability. Now, what is the definition of the workability? Definition of the workability is the ease at which you will mix and place the concrete. Okay, now generally with the increase of the water cement ratio, this workability increases, but as the water cement ratio increases, the strength of the concrete reduces. Therefore, to increase the workability without increasing the water cement ratio, we generally use plasticizers and super plasticizers. Then coming to the next portion, concrete pavements. Now, due to their high bearing capacity and increased stiffness, their specific property not to deform under heavy permanent loads is a reason why concrete pavements are used for. Basically, they tend to carry a huge number of loads with respect to the your flexible pavement. Therefore, concrete pavements are used in the extreme conditions. Generally, these concrete pavements are used as a parking aprons where vehicles are parked, taxiways, in the airport, parking grounds for vehicles of heavy weight, heavy duty industrial floors, floors for handling and storage of containers at ports, industrial floors with high requirements in terms of flatness and durability of abrasion, bridge deck, road pavement in long tunnels, then pavement at toll stations. So these are some of the examples where rigid pavement can be used. Now, apart from this, there are other uses of the concrete as a pavement material. So, like soil stabilization with cement. So, you can stabilize the soil with the cement using the cement slurry or cement paste over it. Then, recycling of pavements with the cement. This is a very cost effective and method. So it is a recent successful evaluations for the restorations and upgradations of worn out pavement from the traffic road surfaces with the least possible environmental strain and a very low cost. Therefore, this method is very much useful. So in this case, what you have to do, that is, whatever portions of the road got damaged, you have to collect the material from that portion. You have to pulverize that material and mix it with the cement, and again you can place it over the damaged portion. So in this way you are recycling whatever material you have previously used for the road aggregate. Now, another type of concrete is there, that is called pervious concrete. So, pervious concrete is a type of concrete where water can easily pass through it or penetrate through it. So, generally, these pervious concretes are used in a parking areas or in the footpath area. Now, pervious concrete is also known as no fines concrete. So, in the pervious concrete, no fines would be added. That is, no finer materials are added, even though its uses as a structural material in Europe, or there are some history behind this. You just go through it. Now, due to its environmental friendly impact, pervious concrete provides the optimal solution where extensive surface coverage is needed. So basically, it helps to restore the groundwater level over a place because water can penetrate through it, and it will increase the groundwater level over an area, thereby it contributing to the sustainable development of a built up area. Its uses has been recognized as a best management practice by the Environmental Protection Agency in the US because of its significant contribution to the pavement materials, as well as in the case of environmental pollutions. So in the case of conventional pavement construction, the surface runoff leads to 90% of the contained surface pollutants directly into the sea and the rivers. Okay, so in case of conventional pavement, so water will be drained off over there and it will mix with some pollutant which is present over the road surface, and it will contaminate the adjacent water body. While when we using pervious concrete, the pollutants are driven instead into the ground where they are being naturally cleaned throughout the biological degradation and natural filtration. So this is basically a pervious concrete where water can easily penetrate through it. Now let us discuss about the basic types of different types of pavements, that is the categorizations of the pavements. So highway pavements is a structure consisting of different material or consisting of superimposed layers, basically that are different layers combined together of processed materials above the natural soil or soil substrate. The below layer is the soil substrate and above that layer there would be different layer, therefore it is called a superimposed layers of processed materials which whose primary function is to distribute the applied vehicle loads to the subgrade. So basically whatever load would be applied over the top surface, that will be gradually got decreased and it will eventually got transmitted into the soil subgrade. Now the pavement structure should be able to provide a surface of acceptable riding quality as well as the adequate coefficient of friction so as to reduce any chances of slip or skid. Now, the ultimate aim is to ensure that the transmitted stress due to the wheel load are sufficiently reduced so that they will not exceed bearing capacity of the subgrade. Now, there are different functions of the pavement like reduce and distribute the traffic loading so as not to damage the subgrade, provide vehicle access between two points under all weather conditions. Suppose you are making a road, that road should be all weather conditions so that that road can be accessible throughout the different seasons of over a year, provides safe, smooth, and comfortable ride to road users without undue delay and excessive wear and tear, meet environmental and aesthetic requirements, limited noise and air pollution, and reasonable economy. So basically, these are the some functions of the pavements. Now, requirements of the pavements. So first one is it should be sufficiently thick to distribute the wheel load uniformly with a limiting value so that the soil subgrade is not affected so much. It should be structurally strong to withstand all types of loading conditions and all types of loads. It should have adequate coefficient of friction so as to prevent skidding or slipping of the vehicles, then smooth surface to provide comfort to the road users even at a high speed. Then it produces least noise from the moving vehicles, then dust-proof surface so that track safety is not impaired by reducing visibility. If there is excessive dust, in that case, the dust can reduce the visibility, and moreover, that dust can also make the surface slippery by reducing the dust, then impervious surface so that subgrade soils is well protected. So if the excessive water can get through the different pavement layers, in that case it will weaken the underlying subgrade layer, which will ultimately reduce the effectiveness of the pavement and long design life with low maintenance cost. Now, there are different types of pavement, and primarily they are classified into two types. One is flexible pavement and another one is rigid pavement. Okay, these are the different layers of the flexible and rigid pavement. We will discuss this with a detail. Now, these flexible pavements will transmit wheel load stress to the lower layers by grain to grain transfer. Now, what is this grain to grain transfer? Suppose in the flexible pavement layer, aggregates are used in the binder course, in the base course, and in the sub base course. So, what happens? So suppose there are different aggregates which are attached with each other with the interlocking properties. Now if load is applied over here, then this load will be transmitted over there, then transmitted over there, then from here to here, then from here to here. Like that it will transfer from grain to grain of the aggregate. Okay, this is called grain to grain transfer of the load. The wheel load acting on the pavement will be distributed to a wider area. So generally there would be some load dispersion. Suppose a load is applied over there, so it is assumed that load would be dispersed at a wider area, generally with an angle of 45 degree with the horizontal. Okay, so that is your load distribution with a wider area, and the stress decreases within the depth as the area of the load would be increased, so therefore the stress over that area would be decreased. Taking advantage of the stress distribution characteristic, flexible pavements normally has many layers. Now as the load will be distributed in a larger area, okay, and over here would be concentrated load. Therefore what will happen, the topmost layer of the pavement, flexible pavement, would be of highest quality because it would be directly in contact with the load, and here stress would be higher. But beyond this layer, the load, the stress would be decreased, okay, as the area is increased. Therefore you can use for inferior materials in the down layers. Therefore you will decreasing the overall cost of the construction of the flexible pavement. Therefore these flexible pavements are designed using layer system. There will be different layers. Now there are different layers of the flexible pavement. First one is surface course, and generally the thickness of the surface course will be vary from 25 to 50 mm. So in the surface course what happens, you will mix bituminous material with some finer material, fine dust, that is stone dust or any other type of sands like fine materials, and make one coating over the binder course. Okay, and between this binder course and surface course there would be a small layer of the only bituminous material, and that portion is called tack coat. Okay, then beneath this there would be a binder course. So generally the binder course would be your aggregate, small size aggregate with the bituminous material. Small size aggregate with the bituminous material. Generally this surface course is or binder course is the extension of this surface course. Okay, to reduce the cost, generally two layers are made. In the binder course, whatever aggregate you have to use a smaller size aggregate, but here the bitumen content would be far lower than the surface course. Now after that there would be a concrete aggregate layers of smaller size. So this course is called base course. Okay, and in between the base course and binder course there would be another layer of the bituminous material which is called prime coat. Okay, beneath the base course there would be sub-base course. Sub-base course is again a aggregate layer where the aggregate would be much bigger size than the base course, and the quality of the aggregate would be inferior than the base course. After that there would be compacted subgrade. So basically after this portion would be subgrade portion. Now if the natural subgrade of the area is weak, you need to provide a compacted portions of the subgrade, and that is called compacted subgrade. And the thickness of the compacted subgrade, if you provide it, would be 150 to 300 mm. After that it would be natural subgrade, that is your natural soil layer. So these are the different portions of the pavement layers and their functions. Now there are different types of flexible pavements. First one is conventional layered flexible pavement, that is what we have discussed, and this is conventional layered flexible pavement. Then another type is there, that is called full depth asphalt pavement. The full depth asphalt pavement are constructed by placing bituminous layers directly on the soil subgrade. Okay, so is there would be no layer of the sub-base, base or binder courses. There would be subgrade layer, and above this there would be a surface course. Okay, so for this reason, the surface course in the full depth asphalt pavement would be thickness is much higher than the traditional pavement layer. So this method is suitable when there is high traffic and local materials are not available. Then another type of pavement is contained rock asphalt mat. So contained rock asphalt mats are constructed by placing dense or open graded aggregate layers in between two asphalt layers. Okay, so there would be bituminous layer, bituminous layers, and in between there would be aggregate which would be dense graded or in sometimes open graded depending on the characteristics or desired properties of the road pavement. So modified dense graded asphalt concrete is placed above the subgrade will significantly reduce the vertical compressive strain on the soil subgrade and protect from the surface water. So what happens over this case? So first here one subgrade layer would be there. Above this you will place one asphalt layer. Above this you will place asphalt layer. Over this some aggregate would be there, dense graded, and over this another surfacing course would be there. So this is contained rock asphalt mat. So if we discuss about the questions, so first one is write a short note on the flexible pavement. So in that case, you will write about this one, that is the flexible pavements and what are the different layers of the flexible pavement and their name and the desired depth of the flexible pavement. Then what are the different components of the flexible pavements? So basically these are the same questions. So these are the different components of the flexible pavement like seal coat, tack coat, prime coat, surface course, binder course. These are the different component of the flexible pavement. And various types of the pavement, flexible pavement. These are the various types of flexible pavement. That is conventional layered flexible pavement, full depth asphalt pavement, and contained rock asphalt mat. So is it clear? Okay.